Good day, educational learners. I am Diane Cole, and today we're going to explore how adaptive learning and assessment work, not just in the classroom, but in real world scenarios like writing, game development, and science. We'll also connect these ideas to math growth and discuss key concepts for understanding the power of adaptive assessment and learning. By the end, you'll see how adaptive assessment and learning helps students and how MAP mirrors this natural real world process. What is adaptive assessment? It isn't just about measuring knowledge, it should actively guide learning. Adaptive assessments do just this by adjusting difficulty in real time. Think about how people naturally improve through feedback, whether it's revising an essay, refining a video game, or experimenting in a lab. Map growth works the same way. As a student takes the test, it adapts to their responses, providing a customized experience that accurately identifies their learning level. To fully understand MAP, we need to explore four key ideas: adaptive assessment, RIT scores, the zone of proximal development, and normative data. Let's look at how these ideas play out in the real world. Writers. A writer doesn't just create a perfect draft on the first try, although many of our students have told us they did. They write, they get feedback, they revise, and then take on tougher challenges. This process mirrors the zone of proximal development, the space between what a person can do independently and what they can achieve with guidance. For example, a new author might struggle with a complex story structure or with meeting the needs of their audience and first readers, but they can improve with targeted feedback. As their skills develop, they tackle more advanced writing techniques and better meet the needs of their audience, moving themselves to the next level. Map growth works the same way. If a student answers correctly, the test presents a more difficult question. If they struggle, it adjusts to keep them in their optimal learning zone, where the challenge is high enough to promote growth, but not so hard that they shut down. This ensures that every student is engaged at the right level for improvement, just like a writer growing with each draft. Game developers don't create a game and release it without testing. They go through alpha and beta phases, gathering player feedback, adjusting difficulty, and fixing bugs. If players breeze through levels too quickly, the developer increases difficulty. If too many players struggle, they rebalance the game. This is exactly how map growth works using the RIT score. The RIT score, or ROS unit, is like a game's difficulty setting that continuously adapts to the player's skill level. It isn't tied to a grade level or an age, but to an ability. If a student gets a question right, MAP presents a tougher one. If they struggle, it adjusts downward. Over time, this process gives a precise measurement of both current ability and growth potential. Just like game developers use play testing to fine tune the player experience, MAP fine tunes its assessment process in real time, ensuring that each student gets a personalized testing experience. Science isn't just about running one experiment either and being done. It's an ongoing process of refining theories based on new evidence. Take the medical field, for example. In clinical trials, researchers collect data from thousands of participants to determine the effectiveness of a new drug. The data from these top trials is then compared to a large representative sample, a normative data sample, to understand how the drug performs across different populations. This gives scientists a clearer picture of its impact, whether it's more effective for certain groups, and how it compares to other treatments. Map growth does the same thing using normative data. Normative data is collected from thousands of students across the country. When a student takes MAP, their RIT score is compared to these benchmarks, showing how they perform relative to their peers. This allows educators to answer key questions. Is a student performing above or below the national average? How does their progress compare to previous years? Where should the instruction be adjusted? Just as scientists update theories based on new research, MAP continually refines its standards as more students take the test, keeping it accurate and meaningful over time. MAP itself is an evolving and adaptive assessment. MAP growth isn't just adaptive at the student level, it's adaptive as an assessment itself. The test changes based on how a student responds, but behind the scenes, it's also evolving over time. MAP uses the RIT scale to track student progress across multiple testing sessions and grade levels, but it doesn't stop there. It gathers normative data from thousands of students, refining its difficulty levels and recalibrating its benchmarks. This means that as educational trends shift, as new teaching methods emerge, and as student performance changes, MAP adjusts to stay accurate and relevant. For example, if students nationwide start improving in math fluency but struggle in word problems, MAP detects that trend and recalibrates future tests accordingly. Just like a scientist refines a theory with new research, MAP continually improves itself, ensuring it remains a reliable tool for measuring student growth. So, why does all this matter? Traditional tests provide a static snapshot, but adaptive assessments promote continuous growth and mirror real world processes. By understanding RIT scores, the zone of proximal development, and normative data, educators can better use MAP to support student learning. MAP isn't just a test, it's a tool for growth. Just like revising a paper, debugging a game, or refining an experiment, learning is an adaptive process. And when we use MAP effectively, we can help every student move forward at their own pace so that the students work with and for their own learning and can become masters of it. Thank you for listening. I hope you have learned something today and that you can take it forward so that you can better use MAP within your own spaces.